Hey guys, in this video we'll be learning about the 3D coordinate system. In Calculus 3, we end up using the 3D coordinate system quite often. Now why do we need the 3D coordinate system? First of all, if you think of the XY coordinate plane, we can plot points that are on 2D, such as this point over here, that's 2, 3. And we can use points to make figures such as rectangles, triangles, irregular shapes, etc. This gives a shape essentially a length and a width, but what if we wanted something that's three-dimensional, like a box? We notice that a box has a length and a width, but it also has a height. This is an example where three-dimensional coordinates come into play, where we can describe points in space as opposed to just a 2D plane. Now we have an idea of the application of 3D coordinates, but how exactly do we use them? Just like in 2D plane, 3D coordinate systems also have an x-axis and a y-axis. However, 3D coordinates have an additional axis called the z-axis, which is perpendicular to both the x-axis and the y-axis. If we're to go back to the box example, we see that we can think of the length and the width as being on the x and the y-axes, and the height being on the z-axis. We know that a 2D plane has 4 quadrants. The quadrant 1 being where the x and y are both positive, and the other quadrants are labeled in a counterclockwise direction. We have quadrant 2, quadrant 3, and quadrant 4. A 3D coordinate system has 8 octants. The first octant being where the x, the y, and the z coordinates are all positive. It's easy to remember the positive orientation of the x, y, and z axes. If you think of the z-axis as the vertical height of the box, if you were to wrap your right hand around the z-axis, your thumb points upward toward the positive z direction. Your fingers point in the positive direction of the x-axis, and your wrist points in the positive direction of the y-axis. And that's called the right-hand rule. Now you might be wondering, how do you figure out how to label the other octants after octant 1? Just like in a 2D coordinate system, the octants are labeled in a counterclockwise direction. It might be convenient to think of the octants as rooms in a 2-story building, each floor having 4 rooms. If you start from octant 1 and you go in a counterclockwise direction, you get octant 2, octant 3, and octant 4. Similarly, to label the bottom floor, start right under octant 1, you go from octant 5, and then octant 6, octant 7, and continue in a counterclockwise direction to octant 8. And that's how you label the octants in a 3D coordinate system. And these walls are planes. Speaking of planes, the planes are labeled based on which axes comprise them. For example, the floor on the first octant is comprised of the x-axis and the y-axis, so that's the xy plane. So you just look at the axes to figure out the name of the plane. When we write coordinates in a 2D system, we use an ordered pair, an x, y format. Similarly, when writing 3D coordinates, we use an ordered triple. Triple because there's 3 components. It's x, y, z in that respective order. Now we know how to use 3D coordinate systems and we know how to label octants, so let's actually plot some points. Let's say we want to plot the point 2, 3, 5, and we'll call this point A. How do we do that? Well, As we mentioned, the first coordinate is the x, the second one is the y, and the third one is the z. And the first coordinate is positive 2, so we come out 2 in the positive x direction, so 1, 2. And then the second coordinate is 3, it's positive 3, so we go 3 in the positive y direction, so 1, 2, 3. So, and then the third coordinate is 5, so we go up 5. 1, 2, 3, 4, 5. And that's our point A. And quick note, I drew these dashed lines just for simplicity, but the point we're interested in is this point over here, right here. The dashed lines were just to make the drawing process a bit easier on me. Now I want to ask you, if we had x equals 2 on a 2D coordinate plane, what would we have? Well, you would have a vertical line. Because the x value has to be 2, but the y value can be anything. Likewise, what if we had x equals 2 on a 3D coordinate system? What would we end up having? Well, the x value has to be 2, but the y value can be anything. Okay. But just like in a 2D coordinate system, but also the z value can also be anything. So we could have anything in this direction also. And what do you know? We end up with a plane. We end up with a plane that has the equation x equals 2. Because the x value has to be 2, but the y and the z value can be anything. So just keep that in mind. Let's do another example. Let's say we were given z squared plus x squared is less than or equal to 25. And we're given this component also. You might be inclined to say that this is the inside of a circle with a radius of 5 on the zx plane. Well, first let's understand what the problem is really saying. Since we're giving this, it tells us that we're dealing with 3D coordinates. If we were given this instead, that would mean that we're dealing with a 2D coordinate system. But now we know that we're dealing with 3D coordinates. So what does that really mean? Well, once again, let's start with drawing the circle on the xz plane. We'll just say that this is a circle with a radius 5. But since it is in 3D coordinates and we're not given the y can be anything. If we were to extend this circle infinitely in the y direction, and it goes on for infinity, we end up with a cylinder that's centered on the y-axis and has a radius of 5. So this is the inside. So this gives the inside of a cylinder with a radius of 5 centered on the y-axis. So when dealing with 3D coordinates, be very careful about things like this. Hopefully I was able to keep this video reasonably short and to the point, no pun intended. If you have any questions, feel free to comment. If you haven't already, subscribe. You can also follow my channel on Facebook and post questions there also. The link will be in the description. And until next time, take care, guys.